I'm going to start to catch up to you guys. Let's see. So now I got 44. Choose 7 to smoke. So we got 7 of these people. And we got 37 of the other people. The formula is almost too nice to believe. It sets itself up. Some of you guys are like, I don't think you know what that phrase means, Jeff. I'm hoping some of you guys agree with me that I got 44 people, I want 7 to succeed. So I want 7 successes, the rest failures. I mean, that's too nice to believe. But we didn't do that on purpose. It's just the way that the work led us. That formula just happens to be really, really nice. You can see the physical idea in it. So let's see. So we got 44. Choose 7. Now here's something some of you guys realize. I'm down. I got to hit over to come back up. That is one of the sucky things about the new operating software in this. So times, what was it, Jeff? 152? And I want 7 of those over times 0.848, and I want 37 of those. So 0.1611. All right, I guess just about 16% chance. What was it, 16.11? That exactly 7 people out of 44 will smoke. And then none of them smoke. Same idea. I got 44 people. Now I want to choose no successes. I want nobody to smoke.
That's the real success.
And then what's going to be up here then? 44, I like it. All of them don't. Now watch this. All right, let's just put the whole thing in, and then I'll show you a little shortcut for this one. 44, choose 0 over times 0.152 to the 0 times 0.848 to the 44. Bam. Now what the hell does that mean? Don't put 7 down. Oh my gosh. That's 700% chance. That's neat. Right? What does that E negative 4 mean?
Times 10.
Good. Times 10 to the negative 4. The beautiful thing about negative scientific notation stuff is it's got to go around the whole number, so there's just going to be one less 0 in front. So it's going to be 0.0007. All right, so it's 0.07%. Or 0.007. You can stop there if you want to. So a level below G's one. And then this is something that's come up before. The probability that at least 1 does something is 1 minus none of them. Because none is the opposite of at least 1. So this would just be 1 minus 0.0007, 0.9993. Let me show you something. Because this is going to happen enough in this class. I know we all have calculators. Ooh. But if I wanted to do 1 minus some decimal, like 0.8149, here's a shortcut. Make all of these 9. How do I make 8 9?
1.
How do I make 1 9?
8.
How do I make 4 9?
5.
And then make the last one 10.
Yep.
Yeah. It's related to, what's 10 minus 8? 2. That's amazing. What's 9 minus 7? 2. That's amazing. So 1 minus 0.8149 is the same thing as 0.9999 minus 0.8148. That's part of the reason why this shortcut works. And again, I know we all have calculators, but the more that's actually in our own heads, the better off we are. Okay, that's just a little side. It's going to happen a lot very soon. All right. There was something up here I forgot to say. How many ways is there, if I have 44 people in here, how many ways can I choose nobody?
One.
One way to choose nobody. So that's one. What's anything to the 0 power?
One.
That's one. So for a probability of none, you just have to put 0.848 to the 44th, because the other two things are 1. It's not really a huge shortcut, but still. All right, so let's talk about these guys. Let me see. I always like to pick on Shaquille O'Neal, even though I don't know if you guys even know who Shaquille O'Neal is anymore.
Isn't he sportsman?
Huh?
Isn't he sportsman?
Sportsman, okay. He is sportsman with the sidekick, towel boy. He was a Laker for a while, and he was a Celtic too, which I still can't believe. Sorry, I'm a Celtics fan, so. Let's say there's some hypothetical basketball player. Let's call him Shaq. And let's say he makes, let's say he makes 30% of his free throws. To be nice. I could pick on, anyway, I just like to pick on Shaq. It's just a tradition now. So he makes 30% of his free throws. If he takes 20 free throws, how many would you expect him to make? Expect how many, sir? Not 7.2, it's 6. Because how many do you expect him to make out of any grouping of free throws? 30%. So what's 30% of 20? It's 0.3 times 20. I'd expect him to make 6. Now, expected is not the same thing as definitely will, right? If he made 7 free throws, am I going to go, holy shit? I maybe would have, but if he made 7, would we go crazy? No. Duh, it's close to 6. If he made 18, would that be something interesting?
That would be unusual.
That would be unusual, exactly. Right? It's almost like he planted you. So the formula, now again, what's another name for expected value? Mean. So we've got a formula for the mean for these situations. I haven't even used the word yet. These things we're dealing with are called binomial probabilities because there's 2 possible outcomes. So here he either makes a free throw or he doesn't. So the mean is going to be n times p. That's awesome. So if you have a binomial situation where you have 2 possible outcomes and a certain fixed number of trials, that's n, you can find the mean that easy. Now the standard deviation would take a lot more math to kind of derive the formula, but the standard deviation formula is square root of npq. Now let's see who remembers this. For a normal distribution, what percentage would I find within 2 standard deviations? So within 1 there's 68%, within 2 there's... Anybody remember? Within 1 there was 68%.
Oh, 95%.
Within 2 there's 95%.
Of the standard, of the traditional bell curve.
For a normal curve. So if there's 95% within 2 standard deviations, what percentage is outside of there? 5% chance. Wouldn't you just agree with calling something that has a 5% chance of happening? I would call that unusual. Yes? No?
Yes.
Sort of like walking outside and seeing somebody who's 7'7". Wouldn't you take notice of that? And try not to be rude, but be like, whoa. Or more like, whoa. Right? That would be unusual. Or similarly, if I saw somebody who was 4 feet tall, I might take notice. Right? Because it's unusual. I don't see it all the time. I like it. So the official definition right now of unusual, this has come up before.
how do you figure out what is unusual or not is within 2 standard deviations of the mean. So anything outside of there, outside of 2 standard deviations of the mean. If you're further away from the mean than 2 standard deviations, then that would be unusual. So let me come back to Shaq. So it was N was 20, P was 0.3. Q then would be what? 0.7. So the mean was 6, 20 times 0.3. What's the standard deviation? It's going to be square root of NPQ. So square root of 20 times 0.3 times 0.7. What's that come out to be? So we can figure out technically, when does the number of free throws he makes become unusual? 7, we can agree, would not be unusual. That is close to 6. And we should know in statistics, the idea of distance is governed by standard deviations. So what is 20 times 0.3 times 0.7? Square root of that. 2.049? Sounds about right. So what's the minimum number of free throws I would expect Shaq to make? The minimum would be the mean minus 2 standard deviations. Let me put this up here. I love all this stuff up here. So the minimum number of free throws would be the mean minus 2 standard deviations. So it would be 6 minus twice 2.049. .9 something, I like it. 1.9, blah. The maximum would be mu plus 2 standard deviations. Go 2 standard deviations away from the mean. So it'll be 6 plus 2 times 2.049, or roughly 10.1. So if Shaq made 12 free throws out of 20, officially I could go, whoa, don't see that every day. That's unusual, right? So right now, the definition of unusual is anything further away than 2 standard deviations. Anything further away than that, we're calling unusual. Later in this class, we're going to be more flexible with the idea of unusual. The example I always love to give is if you work at a nuclear power plant, how far will you let that needle go in the yellow before you start to get up off your ass and look around and say, what's going on? I'd say the minute it gets close to yellow, right? I'm not going to. So my definition of an unusual situation that needs to be checked out would be closer than 2 standard deviations, right? Right now it's 2. Later we'll have, in this situation, what is it? In this situation, what is it? The book's actually going to kind of give us that idea. But we'll just remember, that's why it makes sense. I want to change the definition, because based on what the probability, the outcome could be, blowing everybody up, creating monsters, then I probably want to get off my ass. I want to call unusual more. I want more things to be unusual, so I get off my ass. Okay, maybe. So go ahead and finish out part D and E, if you haven't done that already.
Sounds like the kind of rigor that Sector 7G needs.
And they could have used that, yes.